PowerPoints are really boring, so hopefully this is more entertaining. Let's do some physics. So we're going to repeat a portion of Lab 1 with some different approximations. So from what you'll remember from Lab 1, we had a charged piece of tape and we assumed it was a single point charge. Now from Newton's second law, since this piece of tape has mass, it has a downward force due to gravity. And so what we did is we brought another like charged piece of tape underneath it, and those repelling forces due to the electric fields on each would cause an upward force, this electric force right here. Now what we're going to do differently is instead of assuming that this is just a point charge, we're going to assume that it is multiple point charges distributed along the length of the tape. The key thing here is in order for us to achieve equilibrium, this upward force has to be the same as the downward force from Newton's third law. So with that, let's get into the experiment. So cool, we did it. Now we have some numbers. Basically what we found is that the length of the tape is 0.2 meters, the mass of the tape is 0.0002 kilograms, the distance between the tapes was measured to be 0.0127 meters, and the magnitude of the gravitational force, based on the mass and our approximation for gravity, we found that that force is 0.001962 newtons in the negative y direction. Based on Newton's third law, we can assume that the magnitude of the electric force is 0.001962 newtons in the positive y direction. So there are some assumptions that we have to make in order to perform this experiment, one of them being that the only forces acting on the tape are gravity and the electric force. All the other things in this room that might skew that, we are ignoring. The charge distribution of the tape is uniform. Each tape has the same magnitude of charge, and the approximate distributed and we approximate the distributed forces as 10 points or 20 points as we did in GlowScript. So now we can do a little bit of math and find an approximate value for Q, the charge on a piece of tape. Now we're going to use the same assumption that we did in Lab 1, that the piece of tape can be approximated by a point charge. So from that, we have our force, our measured distance, a value of K. And we can assume that, like we said before, that the charge on the top piece of tape is the same as the bottom piece of tape. And so from all of that magic, we get a Q value of 5.930 times 10 to the negative 9th coulombs. What we're going to do is we're going to compare that in GlowScript and see how our values differ. And so let's have a look at some GlowScript. So we'll start by going through the code, and then we'll take a look at the graphic generated. So right here is where we put in our value of Q. We need to start with something, so might as well start with the value we calculated. Down here is where the bulk of the work is done in these two nested for loops. And basically what we're doing is we're looking at each individual point on the top and comparing them to each individual point on the bottom. Now, with each of these calculations, we are finding a value for the electric field at each point on the top, and we're adding them together into a single value. We're doing the same thing for the force due to the charge on the bottom, and we're adding them together. Now, by adding together all of these dEs and dQs, we get a value for the magnitude of the electric force. Now, one thing to note is that when we run this doesn't look too good. So this white arrow right here is supposed to represent the magnitude of our electric force, but it's tiny in comparison to the gravitational force. What we need to do instead is go through, plug and chug, and find a value of Q that balances these. Now, with a value of 1.7523 times 10 to the negative 8 coulombs, when we run it, take a look. Our magnitudes are both the same, 1.962 times 10 to the negative 3 newtons. And this is important because by Newton's third law, the upward force has to be the same as the downward force in order for these to be in equilibrium. And so the conclusion. We have made an approximation using GlowScript and 20 points, and we have done our original approximation of assuming that the piece of tape is just a point charge. So, from the calculated charge with just a point charge, we got a value of 5.930 times 10 to the negative 9th coulombs. Using GlowScript and 20 data points, we found that our charge was 1.7523 times 10 to the negative 8 coulombs. Why the difference? In fact, the difference is by a factor of 8.72. Why is it there? And which is more accurate? So if you think about it, when we're just taking a point charge, we are looking at one specific point. Our tape is a distributed charge. It is an infinite number of points. So by doing this in GlowScript, what we've done is we've increased our accuracy by looking at more points. If we were to use 100 points instead of 20, we could be getting more and more accurate, but like, hey, 20 data points, that's pretty darn good. So if we were going to try and use one of these values for a practical application, we would much rather use our GlowScript charge because we made an approximation with more data points and it's therefore more accurate. I hope you guys liked watching. Glad you could stick around. Yeah, thanks. That's all too. Bye.